Most of the time, though, when we're doing stuff on the projector like we're doing right now, I'm going to be writing in pen. And some people think that's a little hypocritical, and if you think that, you should get over it, okay? Because if I write in pencil up here, it's really hard to see. Not so hard on the recording, but on the board right now, it's hard to see, okay? Plus, it allows me to use different colors if we need to use different colors to differentiate different things that we're talking about, okay? So let's go ahead and start with this worksheet. Let's start with number 1, because that's a very good place to start, okay? I want you to look at this function right here, and I would like you to tell me the name of this parent function. Can you do that? I know you're having to think. You haven't done that in a couple months. That's okay. Anybody remember the name of this parent function? Anybody remember what shape it makes if you graph it?
It's a straight line.
It's a line, right? Okay. So if it's a line, what's the name of its parent function? Yeah. So turn your paper sideways and let's write linear. L-I-N-E-A-R. Linear. Okay. Now, what shape did you say it makes when we graph it? Okay, so that's a good point. Can we talk about that real quick? By definition, a line is straight. So we don't need to say straight line, because when we're saying line, we're talking about something that's straight. Does that make sense? I'm not making fun of you. I'm just telling you. Oh, okay. Okay. So I want to right here. I want to write that it makes a line when we graph it. It's a line. Okay. Now, what's this thing called?
Is that
It's a table. Okay. It's a table. What numbers do we input into the table?
Your domain and range.
Our domain and range, we'll get to those words in just a second, but if we're talking about X or Y, which numbers do we put numbers in for the table? When we're first guessing, we only choose our X's, right? Where do we get our Y's?
After you put it through the
Yeah, after we put it in the equation. That's exactly right. Okay? So we're going to choose our X's, and our equation is going to give us our Y's. Now, there might be a little confusion. I hope not, though, because if you look at this equation, there's not a Y, is there?
Fx is y.
F of x is y. I needed you to remember that. I'm glad you did. Okay? So, what numbers are we allowed to choose for x? Anything that we want. That's exactly right. We choose anything that we want. Now, are there sometimes better numbers to choose than others?
Yes.
Okay? So do you mind if I go ahead and choose some numbers for this one? Is that okay? So let's choose just some pretty normal numbers. And my definition of normal is different from day to day, so we're going to say these are normal today. Okay? So if I know that x is negative 3, based on this equation, what is y?
Negative 3.
Negative 3. What about negative 2?
Negative 2.
Negative 2. Negative 1. Negative 1. Now, am I just repeating the number over and over again?
No, yes, but you're putting it in.
I'm putting it into the equation, right? I'm saying if x is 0, what is y? Well, y equals 0, so that's a 0. Everybody understand that? Okay, so what about if x is 1? What's y? 1. If x is 2? And if x is 3? 3. Now, does anybody notice something weird?
There's a pattern.
There's a pattern. Okay, so that could be weird if we wanted it to be. But I mean specifically about the table itself.
There's more.
There's 2 zeros.
Look right down here.
There's more.
There's a blank.
Blank space.
Just because the table is that big, do we have to fill in the entire table?
We don't?
We don't.
I've been lied to my entire life.
No, you have not. Your teacher wanted you to fill in the table. I don't care right now. If I want you to fill in the table, I will tell you. Is that fair? Okay? We're okay with this. Because I want you to think back what you know about lines. How many points does it take to make a line? 2. Then why did I make you write 7?
So a line is long.
Domain and range, for example.
Well, doesn't it let us see the line a little bit better?
Yeah.
Yeah? Okay? So let's graph these points onto the graph. Let's plot these points right here onto the graph. If I'm at the origin right now and I'm plotting this first point, what direction do I go? I go down? Are you positive?
You.
From the origin, which way do I go first?
X.
I go X
Sideways.
first. So I have to go left or right first. Okay, so I go left because it's -3. And then which direction do I go?
Down.
Down. Okay? So I know we said we go negative, or we go left first. Do we always go left?
No.
So we either go left or
Right.
We always plot our X value first, and then we plot our Y value, right? Okay, now I know that's pretty elementary, but I have to make sure we're all on the same page before we can go on. You okay with that? Okay, do I need to plot every single point for you really slow? Okay, then you do yours, and I'll do mine. Okay, done. Oh yeah, you're done too, good. Okay, now, here is a pretty interesting question, if I do say so myself. Okay, can I connect these points?
Yes.
If you say yes, I can connect them, how do you know?
Because it's linear.
It's linear. How do you know it's linear?
Because he told us.
I told you. We wrote it down. How did you know it was linear?
Because it's the Y in the domain of range.
Uh-huh.
I don't remember
The
why.
equation.
I just remember when we discussed.
Okay, look right here. How was this expression first given to you? F of x equals x, and what's that called?
Linear. Or parent function.
It's called a function, right? If it's given to you as a function, can you connect the dots?
C.
Yes.
Ah.
Okay? So let me show you the wrong way to connect the dots. Can I do that?
We're all wrong.
Why is that the wrong way?
Because you have to
You have to
connect
go
us
dot
on
to
that
dot.
time.
Well, I mean, I kind of did.
It keeps going.
How do you know that it keeps going?
She said it. She's just quiet. So
It's a function, so it keeps going, right? Now, some people say it keeps going, so it's continuous.
No.
Except they're confusing two words. They're confusing the word continuous with the word continuing. I agree that it keeps going, okay? Because if I put in some more values in this table, if I put in 4, 5, 6, 7, and 8, I would get these points that go right up here, right? Wouldn't I? I would get all these points that go right there. And if I could put in all these negative points over here, I would get these points over here. It continues because it's a function. It's continuous because, what about this point right here? Did I plot that point right there?
No.
But if I put in a negative 2.5, am I going to get out a negative 2.5?
Yes.
So it's continuous because every point on this line, not just the ones I graphed, but every point in between the ones I graph are also make this function true. That's why I can connect it, because it's a function. Okay? So what I like to do is, even though I didn't plot these points, even though they're not in my table, we want to go to the edge of the graph because that gives us a bigger picture of what the function actually looks like. Is that fair? Okay. So let's talk now about domain and range. I know somebody mentioned it a second ago. Let's talk about domain and range. Okay? What is domain?
Does it have to do with your x's?
Yes, it does. That's exactly what it is. It's my x values. Now, in Algebra 2, we have to be able to write our domain two different ways. We have to be able to write it in inequality notation and in interval notation. And by the time we get done with this worksheet, you're going to know the difference. You may or may not know the difference now, but let me remind you if you already know it. Okay? What are the x's allowed to be in this function? Anything, right? Another way to think about it is, how far to the left does this go? How far? It goes all the way, right? How far to the right does it go? So that's my domain. A way I can write that is like this.
I remember that.
What does it mean?
I don't know. I just remember writing it. It was weird.
Yeah, it means all real numbers. All real numbers. Okay? So that's kind of what we write when we're writing an inequality notation. That doesn't really make any sense right now, but it will later on. Okay? Interval notation, however, looks like this. Do you remember that? Okay? What does it mean?
It goes from infinity to infinity.
Okay, so it goes from infinity to infinity. So why did I write negative infinity?
Because it can go both ways.
So is there such thing as negative infinity? There's not. There's not. So why in the world would I write negative infinity? To show that it goes to the left. To show that we're talking about to the left. Infinity is just infinity. Okay? We write a negative infinity right there to tell ourselves that we're talking about to the left. You okay with that? Okay, so that's the domain. What about the range? How far down does it go? All the way? How far up?
All the way.
So all real numbers again. What about interval notation? It's the same thing, right? Negative infinity, positive infinity. Now I've been writing infinity signs for a long time and they still look like that. So I'm sorry. Okay? That's what a lot of people do. Turn it sideways and draw an 8. And then turn it back. I'm okay with that. You do what you need to do, right? One more thing that I want to write here in special things is something we talked about a second ago, but I forgot to write down.
This is kind of continuing from the original.
That's a little bit different than what we're talking about here, but that's okay. Okay? All right, so let's look at number... Oh, anybody else have anything else to say about number 1? Productive. No? Okay. So look at number 2. Anybody know what kind of parent function this is?
Exponential.
It's a good guess.
Linear.
Well, this one was linear. Do these look exactly the same?
No.
Okay, so do you think it might be linear?
No.
So probably not. Okay. Anybody know what shape it makes when you graph it?
It makes a curve.
It makes a curve, specifically called a...
I feel like
You do. Parabola. Excellent. Parallelogram is not quite right. Okay, it should be parabola. Does that help you know what the parent function is called? No? Okay, I'll give you a hint. Starts with a Q.
Quadratic.
Uh-huh. Good.
Quadratic functions.
It's a quadratic function. How do you know it's a quadratic? What's the hint that gives it away? It's squared. Okay? So we're going to write that right here as well. It has a squared term. Now, I know some of you, and I need to make something clear. Okay? Look at my M. My M is outside the box. You need to be okay with that. Okay? You need to be okay with that. I don't always write as small as I need to fit in the box. Sometimes it's okay to think outside the box. Or at least write outside the box. Okay? Okay, so what about our table? Any idea of what numbers we should put in the table?
Probably some positive.
Some positive and negative numbers? That's probably a good idea. Could we use the same numbers we used before?
Yeah,
Okay.
let's do that.
So -3, -2, -1, 0, 1, 2, and 3. Is there a time when those won't be the most appropriate numbers?
Yes.
Yeah, we'll talk about it when we get there. Okay. Any ideas what the y values are here? Just square it, right?
Yes.
Now, for some people, that's a lot easier said than done.
Yep.
Okay? Because guess what people want to write incorrectly in the first box? -9. Why is that incorrect?
Because when you multiply negative and negative, it becomes positive.
Okay, so I think I understood most of that murmuring, but that's okay. Okay, that's okay. I'm getting pretty good at listening to multiple people at a time. But here's the thing: if you take one of our calculators and you put in -3 squared, guess what it says? -9. Because the calculator does order of operations. -3 squared.
It squares it first.
It squares it first and then it multiplies by negative. So you have to be careful about that. But again, we'll talk about that as we go. Okay? You know and I know that -3 times -3 is 9. What about -2 squared? 4. -1 squared? 1. 0 squared? 1 squared? 2 squared? Try again. 4. And 3 squared? 9. Can we plot those points now? Please do so on your own paper. can I connect them? Why?
In a certain way, though.
Because there's a function, right? Now, do I connect the dots like line, line,
No, you
line?
gotta make it curve.
Ooh, this is a smooth curve, isn't it? Okay.
Smooth like pudding.
Smooth like what?
Pudding.
Oh.
Pudding.
I don't really want you to draw on pudding, though. So let's just... Yeah, it would be. Wow, that's pretty good, if I do say so myself. Does yours look like that? Oh, it will. It will after you've done it for 20 years. Okay. Now let's talk about the domain. Okay? Now, a second ago we said domains are x's, right? And we can think about it like how far to the left does it go and how far to the right does it go, right? So how far to the left does this look like it goes?
Probably forever.
Yeah, forever.
Probably forever, but if you're just looking at the graph, how far does it look like it goes? -3, right? Except we drew an arrow, right? Because we know it continues. But that's what I want you to keep in mind. Even though the arrow looks like it's going up, where else is it going? It's out, right? It is going to the left, so how far to the left does it go?
Infinity.
All the way. How far to the right does it go? All the way. So what's my domain?
I real numbers.
All real numbers. And then, very good. Very good. Okay? So same for the range? What? It's fine for you to just say no to your teacher?
Good job, Melody.
How far down does this go?
0.
0. It doesn't go forever, does it?
0.
It only stops at 0. How far up does it go?
Forever.
Forever. So here's where the word inequality, when I say we're writing an inequality notation, it really comes into play here. Okay? So for range, which variable are we talking about for range?
Y.
Our y. Okay? So my y has to be
Greater than 0.
very good. Almost. That's super close. What do you want to say? Oh, greater than or equal to, right? Because it can be 0. We even have 0 in our table, right? And we have a value for it. So greater than or equal to 0. So now do you see why it's called an inequality notation? Okay. Now we have interval notation. Interval notation. So where does it start? 0. And it goes to infinity. Here's what I want you to be careful of. Okay? Look at this. I didn't write a parenthesis this time, did I? I wrote a bracket. Why? Can I tell you? Yeah, it's where it stops. 0 is included in our range.
But we don't write a bracket on 15.
Why do you think we only write a parenthesis on infinity?
So does.
If I write a bracket on infinity, I'm including the end of infinity. Do you know where the end of infinity is?
Nope.
Neither do I.
Y.
Okay? So writing the bracket says kind of like basically I don't know where it ends. Okay? That's not exactly the best way to say it. I will figure out a better way and tell it to you tomorrow or the next day. Not Saturday. I'm not going to see you on Saturday. I mean, I might. I'm just saying. Probably not. Okay? I mean, if you're going to Dublin on Saturday, because I am. Okay, I'll see you Saturday, man. Yeah. Okay. Any questions about this one? Anything anybody else wants to add? Okay. What about number 3? It's a good guess, and I know you guessed that on this one too because it has an exponent, but exponential is when there's a variable in the exponent. Okay. So what's this one called?
It's a cubic.
It is a cubic. That's exactly right.
Hydroponic.
How do you know it's a cubic?
Because
it's cubed.
Because it has a cubed term.
I like the trait. Has a. We just think has a one word.
Has a?
Has a.
Yeah, that's fine with me. We can make it one word. All right, what x values are we going to choose?
Probably.
Same ones? Is that a good idea?
Maybe you should do 1 and 2.
Let's think about it for a second. Okay, let's think about it for a second. What if we chose -3? What's -3 times -3?
Times that
9 times -3. So -27. So is it okay to choose? Yes, because I can find a value, right? Should I choose it?
No.
Tell me why. I can't graph it, right? I can't graph it. So I could put it on the table if I want, knowing that